Hi, welcome to our channel Electromer. In this video, we are going to learn about phases and complex numbers in AC. This is the second part of the video. Before we move to the topic, if you are not clear with the basic concept of complex numbers, please kindly watch out the first part of the video. The link of the video is in the description below. Phasor transform is used to solve problems that involve sinusoids. It could be such as AC voltages or AC currents. We use this phasor transform method. Actually, the phasor transform is used when we deal with the arithmetics with sinusoids. For that reason, we have to do some following steps. The initial step we have to use is we have to transform sinusoids into complex numbers in polar form. Then after, we have to solve the problems using complex arithmetic and then transform the results back to a sinusoid. So this is the way we use to deal with the questions with sinusoids. So here is the way we use to generate a sinusoidal waveform through the vertical projection of rotating vector. So here the value of the waveform of the magnitude is changing with the angle, so that it is generating the sinusoidal waveform something like this. So I hope this animation video will clearly explain you how to generate, how the vertical projection of rotating vector generates the sinusoidal waveform. A phasor is a rotating vector whose projection on the vertical axis can be used to represent a sinusoid waveform. So this is a phasor which holds the sinusoid equation as Vm sin alpha. So here the Vm is the maximum value of the voltage and sin alpha. So here the length of the phasor is amplitude of the sinusoid. The length of the phasor Vm, which will be equal to the amplitude of the resulting sine wave. The angular velocity of the phasor is omega. Here is the angular velocity of the phasor. So this angular velocity of the phasor will determine the frequency of the sine wave. Now let's learn about how to represent AC voltage and current by using phasors. So for that we need a sinusoid equation. This is a simple sinusoid equation. Vt equal to V peak into sine omega t plus 30. So with the help of this sinusoid equation, we can take out two values, or we can determine two values, which is V peak and offset, phase offset theta. So the V peak means the maximum voltage or the amplitude of the sine wave. So here this one is the V peak value and phase offset theta will be 30. Here this is the phase offset theta. So if we have V peak and phase offset, then after we can derive the phasor. So here we have V peak and phase offset theta. So with the help of this V peak, we can determine Vrms. So if we have the V peak value, we want to convert the peak value into RMS value, just we have to divide the peak value by root 2. So before that, the Vrms means voltage of root square. So the definition of the Vrms, which the equivalent DC value of a sinusoidal current or voltage is 0.707 of its peak value. So with the help of V peak, we can determine Vrms just by divided by the root 2. Then after we can write the phasor. So the phasor will be Vrms angle theta. Again I will explain. Here we have the sinusoid equation Vt equal to V peak sine omega t plus 30. So here this one is the peak value, this one is the phase offset. Here we have peak value, then we can convert this peak value into RMS value. For that one we have to divide this peak value by root 2. So we have got the RMS value. Then after we need phase offset theta. Directly we can take out the sinusoid equation. Here is the phase offset theta. Now we are going to learn about how to represent AC signals with complex number. Here the phasor representations can be viewed as complex number in polar form. Here what they are telling is we can represent the phasor by converting the polar form of the complex number. So here is the AC signal which has the value in the sinusoid equation. Et equal to root 2 Em sin omega t plus theta. This AC signal can be converted into the polar form of the complex number. So here is the way we can convert these AC signals into the polar form. Here we have root 2 Em. This value, this Em or E peak value can be converted into RMS value. As I said earlier, if we divided the peak value by root 2, we will get the RMS value. So the ERMS will be equal to root 2 Em by root 2. So the root 2 will be cancelled. Again we will get the Em. So according to this equation, the ERMS will be equal to Em and angle theta. Here the phase offset theta can be directly taken from this equation. Here is the theta. So with a simple way we can represent a complex number, or we can represent the phasor by the polar form of the complex number. Phase difference. The phase difference is angular displacement between waveform of same frequency. So if we want to determine the phase difference, the condition is the waveform should be the same frequency. If angular displacement is 0 degree, then the waveform are in phase. If angular displacement is not 0 degree, then we can tell that one has out of phase by small amount of displacement or a certain amount of displacement. So if angular displacement is 0 degree, then we can tell that one as in phase. If angular displacement is not 0 degree, then we can tell that one as out of phase. Phase difference. Here there are three type of wave patterns are drawn by three different conditions. So if you look at each and every one, here you can see that first one is voltage and current are drawn by two different colors. So here both patterns are in same frequency and there is no any other phase displacement in between V and I. That's why we can call this one as voltage and current are in phase. Here if you look at the B part, current I is leads by some amount of phase displacement. That's why we can tell as I leads voltage V. Here the I lags the voltage V by some amount of phase displacement. That's why we can tell as current I lags the voltage V. So here is an example. If V1 equal to 5 sin 100t and V2 equal to 3 sin 100t minus 30, V1 leads V2 by 30 degree. We can tell as V1 leads V2 by 30 degree. Formulas from trigonometry. So sometimes signals are expressed in cosine instead of sine value. So if you face a question with a cosine value, so the first step we have to do is we have to convert the cosine value into sine value. For that one, we are using the basic trigonometric knowledge. So here are some basic trigonometric. Here cos omega t plus theta. Here we have to convert this cosine value into sine value. Therefore, we have to add with the 90. Therefore, sine omega t plus theta plus 90. Likewise, here sine omega t plus theta. Here we have to convert this one into cosine value. Therefore, we have to subtract by 90 degree angle. Therefore, sine omega t plus theta equal to cos omega t plus theta minus 90 degree. Here cos omega t plus or minus 180 will be equal to minus cos omega t. Sine omega t plus or minus 180 will be equal to minus sine omega t. So with the help of this basic trigonometric knowledge, we can convert one form of the value from the another form. Likewise, if we have dealing with the questions, their signals were expressed in cosine value, we can convert that cosine value into sine value.